All right, so this is for the technical assignment where you are analyzing 2006 ANES pilot study designed to see if we could reduce the social desirability of asking someone if they voted or not, right? So I grabbed that data set. It's publicly available. You can download the whole data set. But I deleted a bunch of variables outside of here just easier for you to locate the three variables that we're going to mess around with. So we have the standard question, very short wording, and then the longer multi-stage questioning, sort of trying to elicit an honest response, explaining to people some people plan to vote, but things get busy, blah, 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 just to try to elicit a more honest answer. So standard question, a longer question, hopefully a more eliciting more honest answers. And then this is a combined variable where they just simply combine the information from these two variables and just say, yes, they voted, no, they voted. One, well, we can run a frequency. One is yes, two is no. We can run that and we see that is true, did not vote, number two, right? So we can go back to the data set. We need to create a variable that is going to indicate whether an individual received the standard question or were randomly given the sort of the test variable, the variable that will reduce social desirability, right? Fairly easy to do, multiple ways to do it. Probably easier to do it in Stata and R, but fairly easy to do it in SPSS. Go and compute a variable. We're going to just call it test. All right, we're going to set it to 0. There's lots of different ways to do this. This is just a quick way that works in this case, right? So we create a variable, a new variable, 0. We're going to recode into the same variable under the transform. So we computed a variable, setting it to 0. We're going to record into the same variable. We're going to test the test variable. Old value is going to be 0. The new value is going to be 1. Basically, if they are given the standard variable, right, or the test variable, the multi-stage variable, we'll set it to that. Click add, so that's going to change the value of the test variable from 0 to 1. Click continue. We're going to choose the if. We're going to choose this if the value of VO6P779 is greater than 0, right? So if it's a 1, a 2, or a 3, right, that person got that question, the alternative question, the multi-stage question, and we'll create a measure that will indicate that. So we click continue, and then you can click paste if you want to keep track of what you're doing, right? We can run that. And then we have a variable that indicates, right, if it got this question. And we can just take a look. We can even run a correlation if we wanted to, or a crosstab to check all these values, right? But we see that if they were given a question here, it indicates that in this variable, right? And so now we have the two variables that we can use to run the study that we're sort of replicating a little bit. Runs a logit, and then we could also do a difference of means test. Difference of means test when the value is simply 1 and 2. You know, you're violating one of the assumptions that the variable of interest is basically interval. So I'm running a t-test. It's going to work. My mentor in grad school is like, yeah, you know, if you violate some of these assumptions of these statistics. The statistical tools are so robust that some of these violations of assumptions are okay, right? And in fact, we basically get the same results, right? So we're going to run a logit, which is what the study did, and we're going to run a difference in means test. So for a logit, traditionally you would set this variable to 0, 1. So we could recode the no's to 0. We're not going to do that. We're not going to do that. We're going to save a step. The math works out anyway, right? We have a categorical variable that has 2 cases, and so it's going to work fine. But traditionally, I like to set it to 0, 1. We're going to skip a step. It will mean that our results will be it will be a positive value, right? More likely to say no, more likely to be a 2. So our logistic regression coefficient should be a positive coefficient, whereas if I remember correctly, the paper had a negative, but the number should be pretty accurate, right? So analyze. We're going to go to where's regression. Here's regression, binary logistic. We're going to put the V 06P775X, which is the combined variable. They did that for us in the data set. And then the test variable, right? We're just going to say the covariate, the explanatory variable, the independent variable is the test variable. And we could put paste, right? There's the syntax for logistic regression, and what we'll find is it is statistically significant, and we have a positive value 0.499, and it is statistically significant, meaning if you're given the multi-stage question, which is a lot longer in wording than the standard question, you have a higher probability to say that you didn't vote, right? And that's what we expected. We're going to get slightly more value, of more no's, right? The value of 2, right? Coded 2. We're going to get more people saying no because we suspect that some people lie and say that they vote because of social desirability. The longer question is going to reduce that, so we're more likely to get more no's. That's what we're confirming here, and it's statistically significant, right? If you look at the paper, they have a negative 0.500, so we're really close, but they coded, I don't know this for a fact, but I can almost bet on it. They coded yeses 1 and no 0, and so they're getting fewer yeses, right? We're saying that we're getting more no's. We're basically saying the same thing, and the number is almost spot on, except that the sign is different. So that's basically what you're going to be doing. You're replicating these steps, and basically what the researcher did, and we found the same results. And this is basically building off the last technical assignment, which you rotated randomly certain question wording. That's what they did in this study, right? They ask a bunch of questions, age, gender, partisan, blah, blah, blah. And then half the respondents approximately got the standard question that's been given in other surveys. And then another half got the alternative multi-stage question. And we find that it seems to be pretty clear evidence that it reduces social desirability, eliciting more honest answers and getting more no's to the question of whether they voted in the last election. All right, until next time.